has what we call general solution. Look at this.
Add these on to
This is still 14.4 notes, but we're just going to add to the homework problems from Wednesday. I'm going to give you a couple more of them, so you'll have both within one revolution and then what we call general solution. So today we're going to look at what's called general solution. General solutions means that you have no boundary. It doesn't matter, you're not bounded by the 0 to 2 pi. You're not looking for the specific angles that are going to give you the value. What you're going to do is figure out how long it takes you to get from that angle to get back to that angle. Is there some revolution that you can add on to it? Are you going to, you get to this angle every pi revolution, or every 2 pi revolution, or is it every pi over 2 revolution like your 45s? Things like that. That's what we're looking at today. It's not a lot different as far as the setup and procedural wise. It's how you write it in the end. So if we have 3 times the tangent of x minus root 3 equals 0, and I'm going to solve for x. Does everybody agree I'm going to add the root and divide by 3?
Yes.
Okay. So I know I have tangent of x is root 3 over 3. So you're asking yourself, what angle has a tangent value of root 3 over 3?
1 over root 3, so 30.
So we're at a 30, so it's 1 over root 3. So I know that has to be at what degree, or what radian? Pi over 6. So in my triangle here, just so you can visualize this a little bit better, I'm at pi over 6. And then what other quadrant is tangent positive? The third. No. What's the measure down here then? 7 pi over 6. Okay, so this problem has 2 solutions. Are those 2 solutions the exact same distance apart from one another?
Yes.
In this example, they are. How far apart are they?
Pi.
Pi. How are you? To go tomorrow, yes, you're right. Tomorrow is Super Pi Day. So if I start at pi over 6 and I add a pi, where do I wind up?
7 pi.
If I go from 7 pi over to 6 back to here, what do I add?
1.
Another pi, right? And every time I add pi, I'm always going to be between these 2 points. So my general solution for this would be my first answer.
Pi over 6 plus pi.
This is like the general revolution kind of thing, right?
It's very similar to that. You're still finding all the values, but you're trying to decide, well, can I make this a more generalized statement as opposed to just being pi over 6, 7 pi over 6? I'm saying that every time I start at pi over 6 and I add pi, I'm still going to have an angle that has a tangent value of root 3 over 3. That's what that says.
Could you also write a minus pi?
We always go positive because we're happy. Yes, ma'am.
Wait, we already did go over this.
We did. I talked a little bit about it, but I wanted to get more involved into it today, so you guys get to see how it works out.
No.
No, I'm good.
No, stop looking at me. No.
Leave me alone.
My hands up, but I don't have a question. No.
I'm trying to remember which ones were easier than
No.
So we have 4 cosine x equals 2 cosine x plus 1. What are we going to do first? All right, everybody's saying subtract the 2 cosine x?
Yeah.
So if I subtract the 2 cosine, I wind up with 2 cosine x. Very good. So the cosine of x is a half. So what angle has a cosine value
pi over 3. 50 degrees.
Okay? So what I want you to do to get 1 and a 2, so this has got to be my root 3, so that has to be my 60-degree angle. Everybody okay with that?
Yes.
Okay. My 60-degree angle is radian what? Pi over 3. So it's at pi over 3. What other quadrant is cosine positive in? Fourth. So if I drop that down, what is this angle now?
Negative
5 pi. 5 pi over 3, que bueno para su clase de matemáticas.
Wow.
Hola, ¿cómo está usted?
Wait, wouldn't it be negative pi over 3?
Nah, remember we're going positive revolution. Okay, we're going positive revolution, okay? So, in this case here, is there a consistent value to go from here to here, and then from here to here? That's not the same distance apart from one another. So when that doesn't happen, what you're going to do is look at it as, okay, when I start here, how long does it take me to get back to there?
Oh, yeah.
No. You go from here, how long does it take me to get back to there? Exactly. So there's a very subtle difference between when you're adding 2 pi versus 1 pi, and sometimes it could be a pi over 2. It just depends on the values that you're looking at. Okay?
A pi over 2. If it's plus or minus.
If it winds up being plus minus the tangent, the plus minus tangent values, when you have your pi over 4, so it's all pi over 4 values. They're all equidistant from one another. So to go from pi over 4 to 3 pi over 4 is just adding half a pi. Half a pi, half a pi. So it'd just be pi over 4 plus half a pi. Worried. I didn't want to just get out of the way there. All right. God bless you.
Yeah, it should, that should be helpful.
All right, oops, I always forget that. You guys do this one. Give me a general solution. And when I say give me a general solution, just don't say pi-ish.
It is pi.
Yeah.
So I'm guessing you guys,
Started talking about the yeah, what do you expect?
perfect timing, right?
What?
Anyway, add 2 divided by 4, take the square root.
1 over minus.
Plus or minus.
1 over.
We okay if I leave it like that?
Yes.
Do I need to rationalize?
No.
I don't, because it's just easier to work with. So what angle is going to give me a sine value of plus or minus 1 over root 2? Pi over 4. So this is the example that when you have a 45-degree angle that's repeated, the 45-degree angles on the unit circle, if you recall, they all had the same endpoints. Root 2 over 2, root 2 over 2 for cosine and sine. Then it just changed the sine SIGN values going around. Therefore, it makes a square. What do squares have? Right angles, yes. And each right angle measures how many degrees?
90.
In radians, then it's... So you have pi over 4 plus pi over 2 and. This is the... Does that make sense why it's going like that? Yes, ma'am.
Oh, wait, never mind, okay.
That was a great question. I'm glad we wasted our time on it.
So if it wasn't 45, say it was like 30 degrees, if they were like in all quadrants?
It's not the same value adding across. And this is a good question here. What happens here, let's say you had all of your 30-degree values. So if you're at pi over 6, this would be 7 pi over 6, 5 pi over 6, and 11 pi over 6.
Pi over 6 plus pi and then pi over 6 plus pi.
Very good. Izzy, what I want you to see here is the only two that have the same distance is going from here to here,
4, 5, 5,
and then from here to here. So you have to use pi over 6 plus pi n, 5 pi over 6 plus pi n. And it works the same if it's the pi over 3s. It's all 4 of those as well. Not so bad? All right. Let me give you, let's see, what did we do here? What I want you guys to do, it's the same section, 14.4. I forgot what page number it was. It's the one page before we just did. What is it? No, it's 9:52. You might not have put your watch ahead.
Hey, man, I think I'm
I think it's 32. Let me just triple check. No, don't do 32, just 31. Sorry, just 31.
Thank you.
Okay? These are all general solutions. Okay? These are all general solutions. All right? Tack these on the ones you guys had from Wednesday. We'll check any lingering messiness on Monday. And then on Monday, we will start simplifying and verifying. So if you happen to have friends that are in the other Algebra 2 classes right now, or Muskoda's class, I think they've been working on this for a while, you'll know their pain.
Why are they ahead of us?
They're not. They're just doing different sections. What we've done is that we did all of chapter 13. They only did a couple of parts. And then they're doing some of the, they've already done the graphing, whereas we're doing it a completely different order because it builds into the more complex stuff that I get to do with you guys.
Wait.
Yeah, I heard it was really hard.
Yeah, we've done that. Graphing is so easy on sines and cosines. It's so easy.
Why is it like,
Yeah.
I just hate it.
No, I'm not lying. I swear to you, I'm not lying. I lie a lot, but I don't swear a lot. Yes, sir. I have no idea. We don't do course selection until,
Wait, that's possible. You guys get to pick.